All right, so we're going to talk about chapter 16. Chapter 16 involves the solubility of ionic compounds and the equilibrium involved. Let's go through. All right, so the solubility, like I said, the solubility and the equilibrium, solubility product, which is going to be a new K value we're going to talk about, precipitation, qualitative analysis, and some complex ions. So for an ionic compound, it can be any salt. So in this case, we're going to talk about calcium fluoride. When that dissociates in water or is dissolved in water, it's going to break up into 1 mole of Ca+2 and 2 moles of F-1. These two ions are aqueous, whereas your reactant is a solid. So when we start talking about the equilibrium, it's really going to only involve your two aqueous ions. So when the salt is added to the water first, there's no ions present, or their concentration is going to be 0 initially. And then as dissolution and disassociation proceeds, the ion concentration is going to go up. The reverse reaction is going to happen. So in solution, obviously, we're not going to see that for ourselves, but those two ions are going to come back together and make that solid. So those two forward and reverse reactions are going to be in equilibrium with each other at a certain temperature for a certain solid. When it attains a state of saturation, so that's called dynamic equilibrium, that's when you've dissolved basically, or you've reached an equilibrium where this rate or the forward rate is equal to that reverse rate. Your Ksp, so it's just the same K that we've been talking about, except now we're going to talk about solubility product, is only going to include the concentration of those product ions raised to the power of their coefficient. So like I said, this is solubility product K. It's going to be a constant, just like it was before. There's going to be no unit there. And we're going to plug in concentration. So that's why you saw brackets in those expressions. It's unaffected by if you have excess, because like I said, at equilibrium, it's that forward rate and reverse rate being equal. If you add more solids don't affect our equilibrium. Neither are the size of the particles. Like we said, that solubility is an equilibrium position. So that's going to have a specific constant, and the only thing that's going to affect it is going to be temperature.